Standard enthalpies of formation are the change in enthalpy that accompanies the formation of 1 mole of a compound from its elements with all substances in their standard states. Now, remember, we're looking at an enthalpy change. We have no methods for determining absolute values of enthalpy, only change in enthalpy. So we can define what we mean by standard states. For a compound, which is a gas, we're looking at pressures of exactly 1 atmosphere. For compounds in solution, the concentration should be exactly 1 molar. And for pure substances, we should either have liquid or solid. For elements, the standard state would be the form in which the element exists at 1 atmosphere and 25 degrees Celsius. So let's take a look at the combustion of methane to give carbon dioxide and water. The change in enthalpy for this reaction is minus 891 kilojoules. We could look at this in terms of the bond breaking and bond making processes in going from reactant to product. If we take our methane, methane has a standard heat of formation or a standard enthalpy of formation of negative 75 kilojoules. So to break up a mole of methane, we require 75 kilojoules. Oxygen is in its standard state, so it does not have to break apart. The change in enthalpy for oxygen gas going to oxygen gas is 0. Now, upon forming carbon dioxide, we have a change in enthalpy of negative 394 kilojoules. And in forming water from oxygen and hydrogen, we have a change in enthalpy of minus 572 kilojoules. If we sum up these enthalpies, we get the change in enthalpy for our reaction of negative 891 kilojoules. So when we're performing enthalpy calculations, keep in mind that when a reaction is reversed, the magnitude of the change in enthalpy remains the same, but the sign changes. When a balanced equation for a reaction is multiplied by an integer, the value for change in enthalpy for that reaction must also be multiplied by the same integer. The change in enthalpy for a given reaction can be calculated from the enthalpies of formation of reactants and products, where the change in enthalpy for a reaction is equal to the sum of products times their change in enthalpy minus the sum of reactants times their change in enthalpy. Keep in mind that elements in their standard states are not included in the change in enthalpy calculation because their standard heats of formation are 0. So let's calculate the change in enthalpy for the following reaction between elemental sodium and liquid water, giving sodium hydroxide and hydrogen gas. We can go to tables and find standard enthalpy of formation for these various elements and compounds. elements in their elemental form have a enthalpy of formation of 0. So sodium and hydrogen gas have 0 value. The tabulated value for the standard heat of formation for water is negative 286 kilojoules per mole. The standard heat of formation for sodium hydroxide is minus 470 kilojoules per mole. We can take the sum of product and reactant, which would be 2 times negative 470 for our products. The heat of formation for hydrogen gas is 0, minus 0 for sodium, plus 2 times negative 286 for water. And we should get a change in enthalpy of negative 368 kilojoules.